Hello and welcome to today's video. In today's video, we are going to learn about the nomenclature of unsaturated hydrocarbons. To be specific, alkynes. Alright, so without wasting much of your time, we'll quickly go into what is important. So, alkynes are represented by they're represented by this. So they have a triple bond. They have a triple bond between the carbon atom. Then they have a suffix. So they have a suffix of YNE. So the first one being ethine, followed by propine, then butane, and then the list goes on and on. Now, in the nomenclature, it's very important that we have to understand their structural representation. So, these alkynes, for example, ethine is represented by this. So, what is important is we should have a triple bond between a carbon and carbon. If we look at propine, we have a triple bond existing, then we're going to have something like this. We're looking at the structural representation of it. So there's always a triple bond, then the carbons. If we look at butane, so obviously it's going to be 4 carbons, but there should be a triple bond presented. Remember, each carbon is supposed to make 4 bonds. Then we'll have the hydrogens around. So that will be called butane. So with this essential information now, we can use what we call the UPAC rules to now give the names of these compounds. Let's quickly go into the examples. So example number 1, we're going to name the following compounds. So say name the following compounds. So now we're going to give different structures, and I will guide on the rules that we're supposed to follow as we name these particular compounds. So we can have something like this. We'll say CH3. So using the UPAC, it's very important to state the position of the triple bond. If I was to name this particular compound, I should start by stating the position of the triple bond. So it takes us back to the counting. So how do we count? So the correct counting is the one which starts closer to the triple bond. So it will be 1, 2, 3. This will be considered as the correct counting. If we go the other way, we say 1, 2, 3. So when we start from this side, we'll notice that our triple bond will be at position number 2. So this is going to be considered to be wrong according to the locant. So the correct counting is the one that gives us the smallest or the lowest locant. So in this case, the correct counting is the one in yellow, where the first carbon is where the triple bond is. So if we're going to name this particular compound, So is we state the position of the triple bond, then the hyphen, then we count the number of carbons in the long chain. So there are 3. So this is propyne. Let's say that is A. Let's look at another example. What of a situation where we have this okay, 2, let's say 3. Okay, let me do this properly. Okay, so let's say we have CH3, then C triple bond, C, then CH3. So in this case, we can do the counting. So we'll do the counting using the yellow. So where we say 1, where we say 1, 2, 3, 4. So here our carbon is at position number 2. If we start from the other side, this will be 1, 2, 3, 4. Still carbon is at position number 2. So in terms of the locant, it's the same. So to mention this particular compound, we'll just state the position of the triple bond. So the position of the triple bond is position number 2. Then the longest chain is butane, because it's coming from butane, 4 carbon atoms. Let's look at another example. So we'll try to make the examples a bit more complex, and then we'll reveal more information attached to those examples. Let's look at something like this. In a situation where we have CH2, C triple bond, CH. Okay, so what happens in a case where you have 2 of those triple bonds? Remember, 2 in chemistry means di. Then what is found in the suffix of these particular hydrocarbons is YNE. So what we do is we just marry those 2 and we say dine. So this means you have 2 double bonds. Quickly we go into the counting. So which one is the correct counting? So 1, 2, 3, 4, 5. When we go the other side, when we do the counting, obviously the locant for this is, if we calculate the locant, is position number 1 we have a triple bond, position number 4 we have a triple bond, which gives us a 5. When we use the other direction, still the first triple bond will be at position number 1, the second triple bond, is at position number 4, which gives us, so the locant is equal. So whichever direction you can use to count, you still get the same answer. So how do we name this particular compound? So this one becomes a bit more interesting. So first you state the position of the 2 triple bonds. So I say position number 1, comma position number 4. I have triple bonds, so there is that recognition that I have 2 triple bonds at those particular positions. Then what is the name of the longest chain? So the name of the longest chain in this case is 5 carbons. So 5 carbons means pentane. Pentane. So in this case, it becomes penta. So it becomes penta. Then you say dine. Pentadine. Hexadine. Octadine. So there is that shift in the naming of these particular compounds. So we introduce a dine to show that there is a presence of 2 triple bonds. Let's look at a situation where you have 3 triple bonds. Then you can pause the video and try it. So in this case, let's look at something like this. We have a triple bond here. We have this. Let's have another triple bond there. And this. And another triple bond there. Yeah. So something like this. So in this case, we're going to count the positions of the triple bonds. So it's a 1, 2, 3, 4, 5, 6. Then you can do the locant of that just to be sure which direction is correct. So at position number 1, I have a triple bond. At position number 3, I have a triple bond. In position number 5, which gives me a 9. Then we can try the other direction also. Well, it's a 1, 2, 3, 4, 5, 6. So for the locant, we say position 1, again position 3, again position 5, which gives me a 9. So whichever direction is correct. Now here we have 3 of the triple bonds. So 3 in chemistry means tri. So it's going to be tri plus 9, then becomes trine. So that's what we're going to use. So here, what will be the name? So we start by recognizing the positions. So 1, 3, 5, then the parent name is 6. So 6 means hexa. So it's going to be hexa, then trine. Hexatrine. So that will be the name of this particular compound. Now, to make it more interesting, let's look at E. Now, imagine where we have a triple bond, then we now begin to have substituents now. So this, then okay, CH3, something like this. So in this case, 1, 2, 3, 4, 5. Our longest chain is a straight chain. So 5, how do we start counting? So the correct counting should start from where the triple bond is. So this would be 1, 2, 3, 4, 5. Remember, this is considered as a substituent, which is a methyl. So if you do the locant of this, if I do the locant of this, I know I have a triple bond at position 1, then I have a substituent at position 3, which gives me a 4. Then, if I start counting from the other side, 2, 3, 4, 5, you'll notice that my substituent is at position 3, my triple bond is at position number 4, which gives me a 7. So this is the wrong counting. So when we follow the yellow counting, so we have at position number 3, I want to use this. So at position number 3, we have a methyl. So we recognize that we have a methyl. Then, what is the name of the longest chain? So again, in the longest chain at position number 1, we have a triple bond. Then the longest chain is pentyne, which is 5. So it's going to be pentyne. So that will be the name of that particular compound. Let's look at a bit more complex. A situation where we have a double bond, and a triple bond in the same question. So let's say we have CH2 double bond, CH, then CH3, and CH3. So here it becomes a bit more conflicting. So when you have a double bond and a triple bond, which one do we prioritize? So in this case, we give priority to a double bond. So we start counting from the carbon where a double bond is closer. So in this case, the correct counting is going to be 1, 2, 3, 4, 5. If we start from the other side, it's wrong because we are very far away from a double bond. Then what is going to be the name of this? So the name of this particular compound is going to be 1. So we recognize the position of a double bond. What is the longest chain? The longest chain is pentene, 5. So we don't complete, we just say, we don't complete it as we write, we just say pentene without putting the E at the end. So we write it as pentene, then we put a hyphen, then we recognize the presence of the triple bond at position number 3, then the family name of the entire, which is yne. So yne is recognizing the triple bond, then 1 is recognizing the double bond. So it can get more complex, but the principle is while we have a triple bond and a double bond, we give priority to a double bond. Let's look at G. I want you to pause the video and try out this. So let's say CH2, we have CH, CH2, CH2, 1, 2, 3, 4. Another CH2, then C, triple bond, then CH. So what could be the name of this particular compound? So remember, the correct counting should start from where the double bond is. So you start from here. So 1, 2, 3, 4, 5, 6, 7. So you know that at position number 1, I have a double bond. Then the entire compound is 7, which is heptene. So it's supposed to be heptene, but we write heptene. Then we have to recognize that at position number 6, we again have heptyne. So at position number 6, we just say yne. So that is a complete name of that particular compound. Let's look at H. And we'll look at one more last example. So let's say we have CH3, CH, let's say 1, 2, okay, we have a double bond here. We have C and CH. Let's say we have CH3 here. And C, triple bond, C, CH2, CH3. So here our interest is to find 6, 7, to find the longest chain, and the longest chain in this case is 8. How do we start counting? The counting should start from the carbon closer to the double bond. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Meaning this is a substituent. So we have a methyl. So how do we write the name of this? So recognize the presence of the position of the substituent, which is a methyl. So it's going to be 3 methyl hyphen. What is the position of a double bond? So we're saying at 2, we have what we can call octene. So we'll say octene. I haven't written the position, sorry. So let me use this. So the position of the double bond is at position number 2, we have octene. Then at position number 5, I have octine. So just pick this and this, and it's going to be 5-tine. So that will be the name of that particular compound. Let me give you a question that you can try as homework. So you can try to write the name of CH3, CH, C triple bond, CH, CH double bond, CH, CH2, CH, then CH3, CH2, then CH3. So you can try out this one and post the answer in the comment section. See you in the next video.